Hi everyone, hope you are well. So this is the third part of our Go channel section. Actually, again, I just found a page about this channel use cases. I just wanted to consume every detail within these use cases because I really like a couple of use cases here, and I'm continuously consume everything here. The last time we did ping pong use case, and this time I will try to handle the channel encapsulated in another channel. So let's get started. Channel encapsulated in channel. Let me try to zoom this one a bit more. Where are you? Dialog. Yes, this one. Sometimes we can use a channel type as the element type of another channel type. You know, when you define a channel, you can define the type of this channel. That means channels are something like pipes. You can put values inside it, but you can also define what will be the type of these values. For example, channel string, channel integer, channel another channel. So I never used this notation, but let's see what happens. Here there is a channel definition, but the value, the type of this channel, hi to newcomers by the way, this is a channel and type of it another channel, and this is a write only channel that accept integer is a channel type, which element type is a send only channel type. You see the left arrow is on the left hand side here. That means this is a channel that you can only send a value, integer value, to this channel. This is our type, and this is passed to this another channel as a variable type, and that's it. Yep, this one. So let's see the example. Main, we define a function, and this function accepts an integer as a parameter, and the return value is channel of int. Okay, this is a channel, send only channel, and the value type is another channel, send only channel, that only accepts the integer. Cool. So within the function we create a request variable, direct initialization, make channel int. So we just initialize a channel variable type. There is a go routine inside it for request range requests. Okay, if request is equal nil and plus increase, else. Okay, so here we define a request. This is a go routine, right? And then it returns requests, this variable type. Cool. And you directly pass a 0 to this function, right? You see there is a function definition, and you directly pass the parameter this function definition. And since you are trying to read something over here or something over here, you need to think about this will be a blocking operation, right? Because you call increase 1000 again. When you say done, you will see this will be a blocking operation. That means there should be something happened here. So let's see again. Here we pass 0 as a value. Here, where this n used, okay, this n is used here on this part. This request is another channel type, right? So channel of int. So if you pass 0 here, and we are trying to iterate this request because you are sending a value to this channel, you're just trying to iterate it. But let's say that the first value is 0, let's say that there is a value inside the channel, then you are passing this value 0 to this request. Otherwise you are saying that n++. This time the n will be 1, right? It was 0 before, and it will be 1 here. What else? Okay, here there is a function definition inside the main function. This time it accepts a done channel, and you basically send a struct. This is a send only channel, and you can provide only the struct variable type. From 0 to 1000 you are trying to iterate this, and you are passing counter is equal to, you are sending nil to counter here. So where is counter? I cannot see it. Is that a global variable? Okay, so this is a main function. This is another, let's say, that global variable that has a type function. Okay, this counter means this one. So let's try to implement this one, encapsulated channel. Folder, created channel. This will be just Go file, encapsulated channel. Okay, let's implement the run function here. Func run. Okay, so first of all we need to define a function here, which is var counter is equal to function. It accepts integer and int. Okay, the return value is very different. Channel of integer. Okay, so inside this function we just initialize a channel again. Let's say that requests make channel okay. So inside here there is a go routine of func. We directly pass a variable here, which is no, we are not passing here. This is a simple go routine, and there will be a for loop here. Inside for loop, if request is equal to range requests. So there is no value here how we are able to iterate this one, because this when you call this function, actually you are passing a value to channel within the main function. This will not be requests. Let's delete this. This will be request, this which is the current. You are iterating a list, so this will be the current one. So if request is equal to nil, there will be something here which is n++, right? Otherwise it will be request n. And I think we pass 0 here. Most probably this will be the initial value of it. Okay, and there should be a return, because there is no return value requests. All right, let's reformat this. And inside the main function, it is a bit tricky. Our main function will be, of course, run here. And there is another function inside it, increase 1000, and we are saying that this will be a function, and inside this function it takes channel as parameter, chan. What about the variable type? It is struct. Cool. And there will be a for range here inside the okay, let me use the short notation. It will be for, if I select for e, it will be a direct iteration. The value will be 1000, and that's it. We are saying counter nil. Okay, what else? And we are saying that done struct. Cool. And then we will use this function declaration below that. Let's define a channel. Keep in mind that this, when you say done as a channel declaration, most probably it will be used for notification that's saying that, okay, I am done with the operation. Because when you use channels, you will see there will be some kind of coroutines, and in order to understand when this operation, the total coroutines finished, most probably you are using a done variable for that. So we call this increase 1000 for the first time. We are passing this done. We call another one, another increase. We are passing another done. And what we will do is we will say done, and we will say another done. So here you are saying that just read value from the channel, consume it, but we are not interested in the value actually, because we are not passing it to a variable. And at the end, what it does, there is another request here, which is the scope is different, by the way. There was a request above, but this is something different. We are saying that just make another chan integer, and this is a buffer channel, and the size is 1. Counter is request, also for that request, and fmt println. This time we read value from the channel, and at the same time we print it. Just reformat it and let's read it. There is a problem here because I couldn't format it. So go to main function, just comment this one. Just add what was the value, encapsulated channel.run, and run. So where is coming this live coding motivation coming from? I have a task list, by the way, and in order to make them cross, I'm just opening a live coding stream and then trying to solve it on the live coding session. So it really motivates me. I mean, I also like to watch another live stream sessions about, especially for these topics. So I'm trying to learn with you during this coding stuff. I already use these channels, but when I have a look at this documentation, I thought that, okay, I don't know channels. That's it. So it is 2000. Let's try to analyze it. So you pass done. This is a channel that accepts structs. So remember, on the previous session, you are not using integer or something like that. You are using struct because it is the variable type that you can have minimum memory reservation on your system. So instead of using integer, so you can use integer and then you can pass 0 as a value, something like that. But do not use that. Use that just struct. Here, the main reason is just notify something. You don't need to propagate any kind of value here. The only reason is just notifying that, okay, there is a value there. When you read it, actually you don't carry the value. There is a channel, which is type of struct. And here we are just executing two Go routines. You are passing this done here, and when you send another done here, you will see on this line, if you do not send any kind of value to this done channel, you will see this line will be blocked. Who is sending a value to this done channel anyway? So you are passing done channel here. You see there is a done channel, and this channel is a send only channel, so you can only send a value here within this function scope. By the way, it is not related to here, this line. You need to focus on this part. This function takes a done parameter, and then you see you here you send a struct value to this done. You are not trying to read something from this done. Okay, when you call this go increase, you will see this iteration will be executed 1000 times. For every iteration, you are sending nil value to this counter. So what is this counter actually? When you check it, it is another function, right? And it returns another type of channel here. If you send okay, here, okay, I need to debug this part. So when you call increase 1000, most probably within this part, so this channel is modified, as you can see here, so this operation will not be blocked. But maybe we need to focus on this part. We are creating another channel, which type of integer, and the capacity is 1. And we are sending this request to counter. Where is counter? Counter is here. And request channel integer 1. Okay, so here you see we are okay, so this one channel integer comes from here, channel integer. So there is a channel, but we are passing another channel to this channel. It is a bit complicated, and we are writing down this request. Okay, let's try to debug this part a bit. Debug. Can you share live coding channels which is you watched? Of course. What is that? So this declaration, during the declaration we are passing 0. That's why you are seeing n is equal to 0. But let's go to the next one. So here, what is a counter? Counter is a channel of int, right? So let's say that you just initialize a variable and there is a variable type of it, channel of int. Here you are sending a channel of int to this counter, because you see this is the value type. We are sending it here, and then we are trying to read request part. So how it became 2000. Okay. Okay, so here when we call the initial increase function, right, when we call it, it directly calls this one. We provide a struct here, and this struct does not have any kind of meaning other than notification, so it just notifies. And when you call this one, you see for every iteration here it is sending a nil. When you check here, if the value is nil, we are incrementing n by 1. So since it is iterating 1000 times, it will increment this n by 10,000 times. So on the initial call, it will be 1000, and when you call the second one, you will see the 10,000 plus one more 10,000, and it will be 2000s. So I think this example is a bit hard to explain the use case. I cannot say that this is a real use case. I mean, if there should be some meaningful examples like ping pong or other cases, maybe it will be beneficial on this part. Okay. Check lengths and capacities of channels. Yeah. Yeah, or that's correct. Check lengths and capacities of channel. We can use the built-in functions len and cap. So we have used this cap. I just heard about this 1 week ago. I never used it. To check the length and capacity of a channel. However, we seldom do this in practice. The reason for we seldom use this len function to check the length of a channel is the length of the channel may have changed after the len function call returns. The reason for we seldom use the cap function for to check the capacity of it is the capacity of channel is often known or not important. Okay. The len function to check the length of a channel is the length. Okay, the reason for we use, we can directly check it, by the way, like this, len len with cap. Okay. Okay, very simple. So let's say that you have an array or channel, something like buffer channel, and array, you just define a slice which we have with a size, let's say that 10, and then when you say cap, you will see it will return 10, but if you say len, you will see it will return 0 because there is no item inside it. So you can think about this. Cap tells you the capacity of underlying array. It can be maybe channel. Len tells you how many items are in the array. That's why you see len is incrementing here, but cap is static for a while. Okay, however, there do have some scenarios we need to use the two functions. For example, sometimes we want to receive all the values buffered in a non-closed channel C, which no one will send values to anymore. Then we can use the following code to receive remaining values. Assume the current go routine is the only go routine tries to receive values from the channel C at present. So there is a for iteration here until you consume everything. Len C is greater than 0. That means you try to consume everything, read value from the channel. Maybe value is equal to C. So this means read from the channel. You iteratively reading from the channel and assigning to value, and then until you reach the end. There is no items inside the channel. So I don't get it, this use case, how we differentiate from a for loop. I couldn't get which situation you are talking about, but if you are talking about cap and len, I think you are not talking about that one. We can also use try-receive mechanism introduced below to do the same job. The efficiency of the two ways are almost the same. The advantage of the try-receive mechanism is the current go routine is not required to be only receiving go routine. Sometimes a go routine may want to write some values to a buffer channel C until it is full without entering blocking state at the end. And the go routine is the only sender of the channel. Then we can use the following code to do this job. Here, so you see, whenever you enter a value, whenever you send a value to channel, the capacity is static, right? I mean, let's say that you just define a channel, buffer channel, and you provided 10. So this value is 10 and it starts from 0. Len of channel is 0. There is no item inside it. But within the for loop, you are sending this value to channel. So first iteration, you just send this value to channel. Then the len will be 1. 1 is less than 10. Correct. One iteration more. 2. One iteration more. 3. Up to 9. You will have 10 items inside it. Then you can quit from the for iteration from here. So you see there is no separate go routine, but there is a for loop here. About the code in the editor. Yeah, that was my intention, by the way. There is an example here, but I think it is not a good example that express this channel encapsulation. I can say that. There is a for loop here. We are calling another function, etc. It is getting a bit complicated, I think. So I cannot support this idea right now. Maybe I need to find another example to really express it. So here they state that instead of creating a separate go routine, you can just create a for loop, and by using len and cap, you can just fill this channel until it's reached the end. Block the current go routine forever. Okay. The selected mechanism is a unique feature in Go. The select, okay. So in order to read from the channel, there are different kind of ways. Select is one of them. The select mechanism is a unique feature in Go. It brings many patterns and tricks from concurrent programming. About the code execution rules of the select mechanism, please read the article Channels in Go. Okay. We can use a blank select block select to block the current Go routine forever. This is the simplest use case of the select mechanism. In fact, some use of for time sleep time second in some above examples can be replaced with select. So you see, if you do not provide any kind of condition to for loop, that means it is an infinite loop, right? This is an infinite loop, but within the for iteration, actually you are putting 1 second delay. So think about an infinite loop, and that has a 1 second delay between each iteration. They are saying that instead of using this notation, you can also use select. That's it. Generally, select is used to prevent the main Go routine from exiting. For if the main Go routine exits, the whole program will also exit. So this reminds me the time that 2005, I think, while I am in the computer science, while in university, our main language was C and C++, and we were using Turbo C compiler. And in first implementation, when we try to execute this code piece, we just see a black flash of the execution, and the terminal is gone. So at the end, we were putting something like system.wait or something like that in order to prevent this terminal to be gone. So that just reminded me. So inside the main function, if you are using Go routines only, you will see Go routines will be executed in parallel, and then your main function will be just exit, because there is no blocking function. They are saying that you can use select in order to block it. Main function, you call do something. If there is no select here, while they are working here in separate Go routine, your main function will directly quit, right? Because there is no blocking operation. But you can also put select here. We can easily simulate this one. Let's say that select block. And just put another Go file here, select block. And in this select block, we can put func run. And what can we say? Go. Instead of calling this, okay, let's just define a function here, func do something. Inside this for runtime dot ghost. Okay. Here we say do something, and we say another do something, right? Let's do not put a select here, and I will comment this one and say select block run. Just run it. Yeah, just exits. But if you put select here, yeah, just reformat and execute again. That's it. There are some other ways. What other ways? Okay, you already know that if there's a channel, if you send a value to inside the channel and nobody reads it, and this will block the operation forever. Receive a value from never closed channel which no values have been and will be sent to. Okay. Yeah, there is no value sent in this channel. It is another block. Receive a value from or send a value to a nil channel. this is also strange, and use a bare select block. Okay. Try send and try receive. A select block with one default branch and only one case branch is called a try send or try receive channel. We use this select statement, but actually there are cases inside this. We will see it most probably. A select block with one default branch and only one case branch is called a try send or try receive. So it is something okay, let's create another folder. Try send select. Okay. Go file, try send select. Okay, here within the for loop you say select, and you can say case here, do something, for example time dot, you can put any stuff here, let's say that nil, and then there is another which is default. So this notation is called try send and try receive. Try send or try receive. Okay. If the operation following the case keyword is a send operation, so there will be a send operation here. Oh, what is this? I think it's just duplicated. If the operation following the case keyword is a send operation, then the select block is called as a try send operation. If the send operation will block, then the default branch will get executed, fail to send. Otherwise, the send succeeded and the only case branch will be executed. Okay. If there is a send operation in the case, we will call this try send. Most probably the other one will be try receive. If the operation following the case keyword is a receive operation, then the select block is called as try receive. If the receive operation would block, then the default branch will get executed, fail to receive. So here you are trying to receive something. If the receive operation would block, then the default branch will get executed. Otherwise, the receive succeeds and the only case branch will get executed. Okay, you are trying to read something. If it is blocking that, you will use default. If you are trying to send something to channel, here in the case statement, if it will block again, then the default statement will be executed. It is something like try catch, nothing different, I think. Try send and try receive operations never block. Yeah, so think about it. There can be some cases for the channels they can block operation, right? But you can just change it. If you use select case default, if it blocks something, then the default part will be executed. Let's have a look at this small example. Function main. There is a type which is called book, but actually it is a struct. Struct id int. We have a book struct that only contains a field which is id integer. Bookshelf make channel book 3. There is a channel that accepts only book type, and this is a buffered channel. The capacity is 3. For loop starts from 0. You see there is a capacity of bookshelf which is 3. 3 times 2, 6, and e++. Select the case bookshelf, this one. So let's think about this. We just initialize a struct, I mean creating a value of struct. ID is 0, right? I am trying to send this value to bookshelf channel. You see here the capacity is 3, so this one will be succeeded, right? The default will not be executed. Okay, the second iteration, you see this time book ID 1, you can send this one to channel. Okay, the length is 2, capacity is still 3, and this one is also executed. Next iteration, you will see book ID 2 will be sent to this channel, and that's it. So you just put 3 values inside the channel and the capacity is exceeded. Then when you go to the next iteration, the value is 3 this time. Then when you try to send this value to bookshelf, you will see it will not be sent there because the capacity is full. At that time the default will be executed and the fail to put book. Most probably we will see succeeded statement 3 times, failed statements 3 times. There is another for loop here. Let's see what is the difference. It seems there is no difference. This time it is read. Okay, this time we are trying to read from the channel. So at first here you send 3 items to channel, right? The remaining 3 you couldn't send to this channel. There are only 3 items inside this channel. Let's switch to this for loop. We are iterating this 6 times. At least we will try to do that. Okay, case book. Try to read from the bookshelf. Okay, the first item is received. Next iteration, second item is received. Third iteration, the third item is received. When you try to receive the fourth item, you cannot do that, so the default one will be executed, default one will be executed, and the final time default one will be executed. So 3 succeed, 3 failed, 3 succeed, 3 failed. Let's check it. Succeed, failed, succeed, failed. This one, very good example. It was very good example. That's my idea, I think. So let's try to analyze this one. So there is a type of book which is struct, and there is only an ID field here. What else? There is a channel bookshelf, and the value is make channel book. The capacity is 3. There is a for loop from I until to capacity of bookshelf multiplied by 2. Okay, select case. The first case is case bookshelf. We try to send a message to bookshelf, right? Here we are saying that book ID I. Okay, if this is the case, we will print a value fmt succeeded to put book. Value is I, and there's the default value here, and same statement, failed to put book. Okay, that's it. Let's copy this one, paste it here. Oh, it is just a wrong copy. Okay, everything is same. I think the only difference is we are trying to assign a value to book. Book is equal to receive value from it, and then delete to this one. We will use it here. Succeeded to get this time. Here, change get. Yep, that's it. So let's try and select run. No, try and select stop and rerun. Can you close site? You mean this one? Oh, yeah. Okay. Yeah, same. It's been 46. Check if a channel is closed without blocking the current go routine. Check if a channel is closed without blocking the current go routine. Assume it is guaranteed that no values were ever and will be sent to a channel. It is guaranteed that no values were ever and will be sent to a channel. We can use the following code to concurrently and safely check whether or not channel is already closed without blocking the current go routine, where T, the element type of the corresponding channel type, is closed. A utility function. You just provide a channel type of T, we don't know what is T, and it will return a boolean. It's closed, true or false. Select KC, return true, default, return false. So you just pass a channel to here. If you can read from the channel, that means true. If you can read from it, you are returning a true. Otherwise, it will return false. The way to check if a channel is closed is used popularly in Go concurrent programming to check whether or not a notification has arrived. The notification will be sent by closing the channel in another Go routine. Okay, so let's say that there are multiple Go routines, and within one of them you are saying that the operation is handled on the second Go routine, and they do something, and at the end they close the channel. Just an example. On the first Go routine, you are trying to select something from it, but if you can do that, it says just return true. Okay, this is just an example. Utility function, we can test it, but okay. Peak burst limiting. We can implement peak limiting by combining use channels as a counting semaphore. We already handled this example. Whenever you do something, you increment the counter by 1. Whenever you finish your job, you just decrement the counter, and when you reach to 0, you are saying that okay, all the operations are finished. And try send, try receive. Peak limit or burst limit is often used to limit the number of concurrent requests without blocking any request. The following is a modified version of the last example in the use channels as counting semaphores. Let's see, can serve most 10 customers at the same time. So let's see, from 0 to, okay, this is an infinite for loop, and you are always incrementing the customer ID. Time.sleep times second. So for every iteration we are trying to put a sleep statement here. Customer is equal to consumer. This is a struct initialization. We are passing customer ID there. Okay. and here we are trying to select from the customer channel. This is a channel, right? Customer, where are you, customer? Yeah, most probably this is a consumer. So no, we are sending a value to this one, this channel. For every iteration you are executing a go routine, right? So first you send value first until the 10 one, so you can send only 10 customer to this channel because this is a buffered channel. If you try to send the 11th one, you will see it will be blocked. But let's say that at the same time this operation is consumed on some other go routine. So let's say that you put some values inside it, you reach to 10, and this channel is consumed by another go routine. If they remove one value from it, you will see you will be able to continue from this for loop. So if you can send something here, you can send, but otherwise you will see customer ID goes elsewhere. Okay, it is understandable. Another way to implement the first response wins use case. So first response wins. Okay. Let's say that you are trying to calculate something. Let's say that very hard integral problem in mathematics. Let's say that you have 5 machines. You are in a distributed environment. You are saying that, okay, 5 machines, could you please get this job done? You send the request. Whoever responds first, let's say that the 3rd machine is completed its job and they return the result. So that one will win the operation, and of course after a while you will get response from the other machines, but you can ignore that results because you already get the initial result from the 3rd machine. And as mentioned above, we can use the select mechanism try send with a buffer channel which capacity is 1 at least to implement the first response win use cases. Let's see. Source main. Here the capacity should be at least 1. There is a channel and the capacity is 1. You are trying to iterate 5 times, and for every iteration you create a separate go routine. So there will be 5 go routines, right? Go source C. We are passing this channel to here. Capacity is 1. So you will see there will be 5 execution of this logic. 5 execution, 5 go routine. Let's say that the second go routine just completed this operation. So completed this operation and say C is equal to this one. So yeah, the random value is passed to this channel. Whoever sends this value to the channel, it will block the operation because the capacity is 1. Let's say that second coroutine sent the value, it blocked the operation, right? And then whenever you get a value to C channel, you will see you will be able to read it from here. You created 5 coroutines. If there is no value to these channels, you will see the operation will be blocked here. Whenever one of the coroutines sends a value to C channel, this operation will be unblocked and you will read the value here. A good example. Let's first response first win. First response wins. There was already an example here, but let's say that first response wins select. Just create a new Go file. First response wins select. I will add our function here, run. Where are you? Here. Okay, there is a function func source this contains a channel, accepts a channel, you can only send to this channel integer 32 run which one? This one. Run that. Okay, as I can assign it cannot get both of the values. Okay. A or B. Time dot sleep. Time dot duration. Duration will be RB. Time second. So this is a random. This will be int n. Okay. This is a random value generation. Let's say that this one, random value plus 1. So for every go routine, there will be a random delay. So they will not all be the same. Here we just say select. Inside select, there will be a case. In this case, we will try to read from RA. If that is the case, there will be nothing. And default, just format it. No, Unix none. Just create a channel type of integer 32, and this is a buffer channel. Buffer channel, and let's try to extract this one to a variable. Let's say that C. There is a for loop. Inside for loop, it will go until 5 goal source C. 5 coroutines, and run is equal to C. So we just read value and then say run. Just format it and run the code. Oh, we executed wrong function. Just comment this and say first this one. It basically returns the random number, right? That's it. there is another one, the third way. Let's read it. The third way to implement the first response wins use case. For a first response win use case, if the number of source is small, for example 2 or 3, we can use a select code block to receive the source response at the same time, for example. Okay, there is a source here. This time it does not accept but returns a channel. Okay, C must be a buffer channel. There is a go routine. We randomly generate. There is a delay. We are sending this one to C and return C. This time it is returning. So select, right? We are trying to, okay, there is a cases here. Every time we are trying to get from source. Think about that. This is a channel. When you say left arrow on the left hand side, you are trying to get a value from a channel, right? And when you execute this one, you will see there will be a separate coroutine will be created. Okay, one sec, I will be back. Sorry for that. Okay, I'm back. Yeah, you basically try to read value from channel, which is source here, and when you try to call it, it is a go routine, right? You need to wait for this delay, random delay. Whoever gets the first one, you will see it will, let's say that the second one, you just received value from second one, then it will return. The round value will be assigned and you can print the value. I think it is not a nearly same example, let's say that. Oh, what it says: if the channel used in the above example is an unbuffered channel, then there will be two coroutines hanging forever after the select code block is executed. This is a memory leak. Okay, let's analyze. If the channel used in the above example, channel is this one. If the channel used in the above example is an unbuffered channel, then there will be two coroutines hanging forever after the select code block. Yeah, of course. So you are basically trying to add more values to here. You read 3 times, and then yes, there will be 2 coroutines at the same time. There might be, at least. This is a memory leak case. Timeout. In some request response scenarios, for all kinds of reasons, a request may need a long time to respond, sometimes even will never respond. For such cases, we should return an error message to the client side by using a timeout solution. Such as timeout solution can be implemented with the select mechanism. The following code shows how to make a request with a timeout. So in most of the use cases, if you are using channels, if you are doing something wrong, most probably you will be blocked, or even there can be some lock here. Request with timeout. It can return a value or it will return an error. There is a channel, may need a long time to get the response. Go do request. We are passing it here, and then after this operation we are trying to select. You see, we are trying to read from the channel, but if there is no value there, this operation will be blocked for a while. And then there is a case statement here. Think about, there are 2 case statements. We are trying to read from it. Okay, if there is no value, you will be blocked here. But there is another case, time after timeout. What is this? Time after timeout. You provide a timeout value, duration. If, let's say that you provided 2 seconds. After 2 seconds, this case will be successfully executed, right? And then you can directly return 0 and errors. Actually, this is also good. I like this case. Request with timeout. Let's try to do this. Folder. Request with timeout. Command and profile request with timeout. There will be a function run. Now what we can say, okay, let's define another function here. Request with timeout. This will get timeout value, time.duration, and then it will return an integer or error. And C is equal to make channel type int go, let's do some function, let's say that. And we are passing a value C here, and this will be channel integer, right? Because this is a channel, I am passing it here. Let's say that I am doing nothing inside this part, and there will be a select statement. Select statement. There will be a case, and at first I will try data. I need to read from it. See if I can read it, return data, and the error will be nil, right? If there is another case, which is we are trying to read from time that after duration will be timeout, and you are saying that return 0 and errors.new, the value will be timeout. What we say, request with timeout. Let's say that time dot second multiplied by 5. What can we say? Well, I don't need to. Okay, just handle error. Let's say that. Just assign a value, timeout error, and we will print timeout and error. And inside main function, just comment this and add request timeout run. Let's see. Yeah, since we provided 5, it returns 0 for the data, and it returns timeout value. Let's say that here, if you send C 5, if you directly send a value here, you will see before the timeout it will print the value. That's it. Ticker, let it be defined in example. By the way, we already overreached the 1 hour period. Ticker, you know, the time ticks, tick tick tick. This is the operation. We can use the try send mechanism to implement the ticker. Tick, you provide duration, and this time it returns a channel of struct. Most probably this is for notification. You just it should return a receive only channel. Okay, define another channel struct, buffered one. You define go routine. Within the for statement, you are saying that just do a delay for this one. You are trying to select. If you can send value, struct value to this channel, C. Okay. So there is a go routine, only one, but keep in mind that this is an infinite stuff. There is a delay at first, and when you try to say select, this time you are trying to send some value struct into it. And you see there is a buffer channel, the capacity is 1. You send the first one. if you try to send second one, it will be blocked, right? But at the same time, this returns a C channel. Here you are saying that for range tick time second, for range tick. In fact, there is a tick function in the time standard package, provides the same functionality with a much more efficient implementation. We should use that function instead. Look and clean. So this returns a receive only channel. When you try to iterate it, actually you are trying to read from the channel. That's it. Every time you are receiving a value from channel, but on that there will be a duration, delay of that duration there. I think this is also a good example. Let me try to see it. Let's say that tick and no. Go file tick func run, let's say that, and we will implement a tick function. Func tick, this tick just accept a time dot duration, and the return value is receive only chan struct, no string struct. Okay, here we just define a channel struct, and the capacity is 1, and go func for statement. There will be nothing here, and there will be direct delay, and select case. This time see, I need to send a struct here. There is no, there is one default, there should be one default here, and we need to return C here, right? So our function is completed, and we will call it here. T is equal to time dot now, then for range tick, no tick tick, time dot second. For every iteration we will time dot since t. Cc tick dot run. Something like this. Okay, let's finish it here, and on the next session we will have a look at rate limiting. Actually, there are lots of use cases on this part, and I believe that this part will be also funny. Rate limiting, you know, we are using rate limiting to define the boundaries of our products, of our systems. For example, you can restrict customers, saying that okay, in per second you can just send 3 requests per second, something like this, to the customers. Or you can say that if you reach the 10 requests per second, I will put another delay to your responses, something like this. Yeah, that's it. We try to make around 6 or 7 use cases today, and see you on the next session if you don't have any other question. Yeah, I can wait for 1 minute. limiting, switches, control code execution, data flow manipulations. Okay, thank you all. Then have a nice day, have a nice evening, have a nice night. See you in the next session.